What we want is the x's on one side and the other like terms on the other. So let's start with something. Pick something. You like having the x's on the left? Is that the way we usually like it? Let's think it through. In order to get rid of this positive 4x on this side and bring it over there, what am I going to have to do to that positive 4x? Yeah. I'll have to subtract it. What's already there? Mark. A negative 8. So if I do that, if I go that route, I'm going to be working with a negative x. Are you okay with that? Or let's think of the alternative. If I move the negative 8x over here, what's the opposite of the negative 8? How am I going to get rid of the negative 8x? If I add 8x to this side, what am I going to have? Positive 12x. You want to go that route? Let's do it. So we're going to add 8x to this side. Let's take a minute to simplify. Let's rewrite what we're working with now. Here's my 7, and it equals a 4x minus 17 plus an 8x. Can I tighten anything up over here? Any like terms that I can work with and tighten it up and clean it up a little bit? Marlia? Yeah, you already told me that we were going to have a 12x. Here's my negative 17. There's my 7. So if I've got my positive 12x over on this right side, I need to get rid of this negative 17. How? Marlia? Both sides. So 17 plus the 7. Okay. What is 7 plus 17? Raven? Becoming clearer now? Okay, divide both sides by, and x will equal 2. It wouldn't matter. If we wanted to move that 4x and bring it over there, it still would have been fine. We still would have got a 2. As long as you do the opposites and you do the computation correctly, you're going to be fine. Let's look at this original. The 7 minus 8x is equal to the 4x minus 17. Let's plug in the 2 and see if it works out. Both of these sides should be equal. So what is 8 times 2? 7 minus 16. 7 minus 16. Negative 9. Let's plug in the 2 here. 4 times 2? 8. 8 minus 17. Does negative 9 equal negative 9? 2 is our solution. Okay. This one actually kind of takes a step back from what we just did. So it should be even easier to figure. What do you want to do? Raven? To where? Add 3m to both sides. Obviously, adding 3m to both sides is our best option at this point. 24 will then equal how many m? And then from here, it should be relatively clear, right? Divide both sides by 8. And 3 is equal to m. So we've done this already, but instead of moving around the values, the terms that had variables, we were just moving around the regular terms. You can do the same thing with the terms that have variables. You just do the opposite, just like you've been doing. It works the same way. Okay. Here, I'll give you one to try. 20 plus c. How many c is this? 1. Good. Is equal to 4c minus 7. Okay, what route did you take? What did you do first? What did you move first? So you moved the 4c? So you moved to the other side. Okay. How did you move the 4c? If it's a positive 4c, how did you get rid of it over here? Subtracting it from both sides. So what you ended up with was a 20 plus a c minus a 4c equals negative 7. Right? Watch. Next step. Can we combine a positive 1c with a negative 4c? And what do I end up with? Negative 3c. And there's still that positive 20 and a negative 7. What needs to go? Positive 20, how? Subtract it from both sides. Negative 3c is now equal to what? Positive. So you start at negative 7, you subtract 20, you get positive. You're already at a negative. Negative 27. So, divide both sides by what? Negative 3. C equals? Positive 9. Now, how many of you went the other route? Maybe you moved the C. You still got 9. So like I said, it doesn't matter what you move, as long as you do it correctly, you'll still end up with the right solution. Okay, we got to stop mixing up our positives and negatives. That's murdering you. Absolutely murdering you, killing you. Another one. 9 minus a 3k is equal to a 17 minus 2k. Where are we going? What are we doing? What option? What do we do? Raven. Added 3k. So a 9 is equal to a 17 minus 2k plus 3k. So I'm at a negative 2. I'm going to add 3. Where does it put me? Positive 1k, which is just like saying positive. Yeah, just like saying positive k. So 17 plus k equals 9. Subtract 17. So if I'm at 9, I subtract 17 equals k. 9 minus 17. Negative 8. 1 is the same as 1k. K is the same as 1k. Just get in the habit of just writing k. Okay? Glad I can be entertaining to you, Maria. All right. If you can't laugh with me, at least you can laugh at me. Okay, now what's the only difference with this one? Get to the line of scrimmage, scope out the defense. What's the only thing difference? Marlia. And you're going to have to use what property? Distributive. You have to use a distributive property before you start moving stuff around. So give it a shot. What do you got to lose? You were fine up to a point. You were fine up to a point, and then you just kind of got lost. So let's just recopy this side until we get this parentheses straightened out. 2 times the 3z, 6z, 2 times the negative 4, negative 8. Okay, so you're good here. Now, if you logic it out and you game plan ahead with the z's, if I move the 5, I'm going to subtract 5 from 6. Is that going to leave me a positive or a negative z? So maybe that's the route I want to take. Not to say that I can't move the 6, I would just get a negative z. Right? Do you see that? So let's go that route. Let's move the 5. Let's subtract 5 from both sides. So here's my negative 2, which is left. Don't forget about the negative. A 6z minus 8 minus a 5z. There's that 5z that I brought over. 6z minus 5z leaves me how many z? Z. There's my negative 8. There's my negative 2. Get rid of the negative 8 by doing what? Adding it to both sides. So a negative 2 plus 8 is equal to z. Six equals z. Okay. Did you see where you kind of got mixed up in the... The other benefit of looking ahead and trying to move the... What it comes down to basically is if they're both positive, you want to move the smaller one. Move the 5, don't move the 6. Taking 5 from 6 will leave you positive. Taking 6, when you only have 5, will leave you the negative. Then you got to worry about dividing by negative 1 and switching the signs around, which isn't an impossible feat, but it's just one more thing you got to do. And in algebra, if you can limit the things that you have to do, it limits the avenues that you can go wrong. Keep it as simple as you possibly can. All right. We'll start light today. So let's do 157. And we can handle 3 through 8. 6 problems.